So 5.1 goes over solving systems using the graphing and substitution methods. In part 1, which we are looking at right now, we are focusing mostly on graphing. We're going to look at a system with two equations in it. Some of them we're going to be working with ordered pairs to tell whether or not the ordered pair is a solution. Others of them we're actually going to be graphing them to see where the two lines cross to see what our solution is. So a system looks like what you see here, where you have two equations with x and y in them. With our first equation that we're looking at here, we have 2x plus y is equal to 5. We also have the second equation, that's 3x minus 2y is equal to 4. With these systems, you can solve these using different methods. We're going to focus today on graphing. However, the first thing we're going to look at is to see whether or not an ordered pair is a solution to this system. So the ordered pair that we're going to be working with is the ordered pair 2, 1. The first number within your set of parentheses is your x value. The second is your y value. For your x value, plug that in. Your y value, plug that in. See if you get a true statement once you simplify everything. If you do this for both of those equations and you get true statements for both, the ordered pair is a solution to the system. If you only get one of the two as true statements, it is not. Or if both of them are not true, it is not a solution. So if we look here, the ordered pair 2, 1, the 2 we plug in for x, the 1 we plug in for y. In the first equation, we have 2 times 2 plus 1, which is 4 plus 1, that's 5. 5 is equal to 5, so we're on a good start here. If you do that and the first one gives you a false statement, there's no need to check the second one. But in this case, we do get the true statement on the first, so we are going to check the second. Again, the 2 goes in for x, the 1 goes in for y. For the second, that gives us 3 times 2 minus 2 times 1. The 3 times 2 is 6. The negative 2 times 1 is negative 2. 6 minus 2 gives us 4. 4 is equal to 4. That's a true statement as well. So since both of these equations are giving us true statements with this ordered pair, that means that the ordered pair 2, 1 is a solution to the system. With the next examples that we're going to look at, we're determining whether the given ordered pair is a solution set for the given system. Bless you. Thank you. For A, we're given the ordered pair 2, 5 with the system x plus y is equal to 7 and 3x plus 5y is equal to negative 19. We're going to plug the 2 in for x, the 5 in for y, and see if this gives us true statements for both of the equations. For the first equation, we're going to have 2 plus 5 is equal to 7. The 2 plus 5 gives us 7, and 7 is equal to 7. So that one is a true statement. You do need to check the second one, though. We have 3 times x, which we said is 2, plus 5 times y, which we said is 5, is equal to negative 19. The 3 times 2 is 6. The 5 times 5 is 25. 6 plus 25 is 31. 31 is not equal to negative 19. So because this one does not give you a true statement, the ordered pair 2, 5 is not a solution. For example B, we're given the ordered pair negative 3, 6, with the system y is equal to negative 2x and y minus 3x is equal to 14. For the first equation, we have y is equal to negative 2x, so that negative 3 is going to go in for x. The 6 is going to go in for y. So that's going to give us 6 is equal to negative 2 times negative 3. The negative 2 times negative 3 is 6. 6 is equal to 6. That's a true statement, so let's move to the next. For the next one, we have y minus 3x is equal to 14. So if we plug the 6 in for y, the negative 3 in for x, that gives us 6 minus 3 times negative 3 is equal to 14. From here, the negative 3 times negative 3 gives us a positive 9. So that's 6 plus 9 is equal to 14. The 6 plus 9 is 15. This 15 is not equal to the 14. So since this one gives you a false statement, once again, that negative 3, 6 is not a solution. The next thing that we're going to look at is solving systems by graphing. When you solve systems by graphing, you're going to be given two equations. Sometimes they'll be put in slope-intercept form for you, sometimes they won't. Either way, make sure both equations are in y equals mx plus b form. From there, use your b as your y-intercept, plot that point first. Then use your slope to find your next point. From your first point, go up or down and to the right using your slope. Once you have at least 2 points, you can draw a line through those points, making sure that that line extends throughout the entire coordinate plane, and draw arrows at the top and the bottom. Do this for both of those equations. Once you have both of those equations graphed, wherever those two lines cross at or intersect, that ordered pair is your solution. In some cases, the two lines will overlap one another or never cross at all. Those are special circumstances. So if you look at the three graphs that you see here, the one on the left, the graph actually crosses at an ordered pair, which is this ordered pair here. So that is your solution, which is 2, 3. So the solution on that one is 2, 3 because that's where those two lines cross at. However, that middle one, the two lines overlap one another. So when that happens and they're the same equation or they overlap, that means that you have infinitely many solutions. Not all solutions, but infinitely many solutions. The entire graph is not covered, so the only solutions that are there are the ones on that line. So it's infinitely many solutions. Then lastly, the graph on the right, you have no solutions because those two lines never intersect. They are parallel to one another. When they are parallel to one another, they will have different y-intercepts, but the same slope. If there's different y-intercepts and the same slope, that means they will never intersect. If we look at some examples, we're going to make sure that these lines are written in slope-intercept form. Plot the points, draw the line through them. Where the two lines cross at, that's your solution. For example A, you're given y is equal to x plus 2 and x plus y is equal to 4. For that first line, that top line, I'm going to graph it in this pink color so that way you see the difference between the two lines. You have a y-intercept of 2. So we're going to plot our first point at 0, 2. Then you have a slope of 1. So we're going to go up 1 to the right 1, up 1 to the right 1, and keep doing this throughout the entire coordinate plane. You can do this, or you can just draw your line through those points. I like to make sure that my line is as precise as possible, so I try to draw as many points through the graph as I possibly can. From there, my line goes through my points, and I move on to my next. My next equation is x plus y is equal to 4. For this one, we got to solve it for y. So we're going to move the x over by subtracting it from both sides. And that gives us y is equal to negative x plus 4. So with this one, we're going to start at 4 on your y-axis. Then go down 1 to the right 1, down 1 to the right 1, and keep going. So that way your line crosses through the entire coordinate plane. You can also go up 1 and to the left 1 if you needed to. So from here, we draw the line through those ordered pairs. And see where they intersect. These two lines cross at this ordered pair here, which is the ordered pair 1, 3. So that 1, 3 is your solution for this system. For example, B, you have 2 times y plus 2 is equal to x, and x minus 2y is equal to 4. For this one on the top equation, we're going to take this 2 and first plug it in, or distribute it in to that y plus 2. That's going to give us 2y plus 4 is equal to x. We want y by itself, not the x. So we're going to move the 4 over first by subtracting it from both sides. That gives us 2y is equal to x minus 4. Then we divide each side by the 2, and that's y is equal to 1/2 x minus 2. For this equation, our y-intercept is -2. So we're going to put our first point down at -2 on the y-axis. From there, our slope is 1/2, so that tells us to go up 1 to the right 2. So up 1 to the right 2, up 1 to the right 2, and I'm just going to keep doing this throughout the entire coordinate plane. I can also go down 1 and to the left 2 to get the other side of this line. So from here, we draw a line through these points. And then we can move on to our next. Our next, we have x minus 2y is equal to 4. So for this one, we're going to subtract the y over first. That gives us -2y is equal to -x plus 4. And then we divide each side by the -2, giving us y is equal to positive 1/2 x minus 2. So for this one, our y-intercept is -2. Then we go up 1 to the right 1, and down 1 to the left 1. Or sorry, down 1 to the left 2. And this gives us the same line that we already have. So because these two lines overlap each other consistently, we have infinitely many solutions. For example, C, we're given 2x minus 3y is equal to 6, and 3y minus 2x is equal to 3. For the 2x minus 3y is equal to 6, we start by moving the 2x over and subtract it from both sides. That gives us -3y is equal to -2x plus 6. Then we divide each side by the -3, and that leaves us with y is equal to positive 2/3 x minus 2. So we're going to start this one at -2 on our y-axis. Then we're going to go up 2 and to the right 3. Up 2 to the right 3. You can also go down 2 and to the left 3 to get the other side of that line. So this is going to give you a line that looks like this. From here, we're going to take that second equation, which is the 3y minus 2x is equal to 3, and solve it for y. So this one, we're going to move the 2x over by adding it to both sides. That gives us 3y is equal to 2x plus 3. Then we divide each side by the 3, and we have y is equal to 2/3 x plus 1. So this one, we're going to start at 1 on our y-axis, then go up 2 to the right 3, up 2 to the right 3. Keep going if you need to. You can also go down 2 into the left 3. And then draw our line. You'll see that these two lines will never intersect one another. They have the same slope, but different y-intercepts in their equation. So this one gives us no solution. For our last example, D, we have 1/2 x plus y is equal to 3, and -6x plus 3y is equal to 21. For that 1/2 x plus y is equal to 3, we're just going to move that 1/2 x over by subtracting it from both sides. And that gives us y is equal to -1/2 x plus 3. So we start at 3 on our y-axis. We're going to go down 1 to the right 2, down 1 to the right 2, down 1 to the right 2, and keep doing that until we get through our entire coordinate plane. We're also going to go up 1 to the left 2, So then we draw our line through our points. And then start on our next line. So on our next one, we have negative 6x plus 3y is equal to 21. We're going to move the 6x over by adding it to both sides first. That gives us 3y is equal to 6x plus 21. Then we divide each side by that 3, and we get y is equal to 2x plus 7. So your 7 starts us off on your y-axis. Then we're going to go up 2 and to the right 1, up 2 to the right 1. We can also go down 2 and to the left 1, down 2 to the left 1. So this one is going to give us the line that looks like this. We're going to look to see where these two lines intersect. So this happens at this point here, which is the ordered pair, negative 1.5, comma 3.5. So with some of these, they won't necessarily be on a vertex. For you, it'll be in between two, so you just have to double check it and look at exactly what it says.